today we are going to go over how to choose the best method for solving a quadratic, because we've run into multiple methods and we want to try to find one that's most appropriate and most efficient for solving things, which can be helpful for you on your test. So we're given a quadratic here, and the first thing we're going to want to do with this is we're going to want to graph it, and we're going to see what its roots look like. So, clear this. And so I would recommend, if you have your graphing calculator with you, pull it out and graph this along with me so you can review the steps, and that'll always help as well. So we're going to first put it in. So we got x squared minus 4x plus 4. And then we'll hit graph and see what he looks like. And so we already see that he only touches the axis at one point. And so we already know that we're only going to get one root. And to find this 0 for this root, we're going to hit second trace and then go down to our 0, hit enter. And we're going to get this little blinky guy. And we will move our dot right over to the left side because we want a left bound of our root. And we'll hit enter. And now it's going to ask for a right bound. So we'll go just to the right where we cross. And we'll hit enter as well. And now it says guess. We'll hit enter a last time, maybe. And that will be our 0. So it's 2.0009, which the calculator is basically estimating for us that our answer is going to be x equals 2. So now that we know what our answer should look like in the end, what method do you think would be most appropriate for solving this? Well, we just graphed it, but we're choosing from factoring, quadratic formula, or completing the square. Factoring. So because we know we have an easy rational number, factoring is most likely going to be the most efficient and easiest option for us to do right now. All of these will work, but factoring is probably just going to be the simplest for us to do. And so we'll write down so when we want to split the middle, we need to find 4 times the coefficient in front of this x squared. So it's really just a 1. So we'll take 4 times 1, and that'll give us 4. And now we need to think, what are some factors of 4? And so we can get 2 and 2, or we can get 1 and 4, and those should be all our factors of 4. Now we need to think which of these factors are going to be able to combine together to get -4. So what do you think, Bradley? -2 and -2. So we're going to have x squared, we're going to have -2x minus -2x plus 4. I'm going to just write up there. Equals 0. So -2x minus -2x, those two combine together to equal -4x that we have above. And so now we have to think, what is a common factor that we can pull out of each of our sides? So x squared minus 2x. Can you think of a common factor that's in both of those that we can pull out? Jordan? X. So x squared has an x in it, and -2x has an x in it. So x squared, if you pull out an x, will be just left with x, and then -2, if you pull out an x, is just -2. Now we have to do the same thing. What is the factor that we can pull out of negative 2 and 4? Correctly. Negative 2. So negative 2x, we pull out a negative 2. That would just be left with x. But what happens when we pull a negative 2 out of 4? What will we be left with? So 4 divided by negative 2, that's going to give us a negative 2 as well. And so now, both of these sides have a x minus 2 in them. So we can factor out a whole x minus 2. And then we're left with what's on the outside. So we have another, sorry about that, x minus 2. And this is equal to 0. So we can use the zero product property to solve for x. So we can get rid of one of these x minus 2's by dividing them. And we're left with x minus 2 equals 0. And now, last step, we just get x by itself. We added 2, and we're with x equals 2. And if we look all the way back up to the top, that's the same thing we got for our graphic. So once again, on our next problem, we want to graph them first, and we're going to see what his roots look like, and then we'll choose our method of choice. Okay, so he's going to be x squared plus 6x. Nope, that's wrong. Minus 11.
You gotta go back there. You typed it in
I'm sorry.
Road, and then this is where. Oh, probably a good idea.
So we have x squared plus 6x minus 11. Okay, that's right. We'll hit graph to see what he looks like. So we see that this graph is crossing the x-axis at 2 points, so we know we're going to get 2 answers. So to find them, we'll hit second trace, go down to our 0, or hit 2, either works. And then we need to find our dots. There it is. And so we need our first left bound. So we need to go just left of our x-intercept. So that's going to be just above. We'll hit enter. And we'll go just below for our right bound. Enter again. We'll have our 2 bars. And then we'll enter, and then give us our guess. So it says negative 7.47. We'll round it to the nearest hundredth, because this is a nice long irrational number. So we got negative 7.4. That was our first root. And now we'll have to do it again to get our second. So we'll hit second trace again. Go down to 2. Enter. And now we need to send our dot over to the other side. Probably easier for you than me. There it is. And then we'll put them just below, because we need another left bound, so we'll put them just left of our x-intercept. Hit enter. And then we'll go just right of our x-intercept for our right bound. Hit enter again for our guess. And we have 1.7, another irrational number. So we'll leave it at the nearest hundredths again. So we see that both of our answers are irrational. We're going to get 2 irrational answers for our solutions for this quadratic. So what do you think will be the best method of choice for this one? Completing the square. I would agree with that. Quadratic formula would also work, because quadratic formula and completing the square are about the same level of like power, I guess, for solving a quadratic. But for this one, I would just recommend completing the square. I think it'll be a little bit easier rather than doing the whole quadratic formula. So we'll write down. And just like our practice, what is the very first step that we need to do when completing the square? Yes, Tiffany? We need to move all of our constants to one side and all of our variables to the other. So we're going to add 11 to the other side. And now, what is the next step that we would like to do for completing the square? So, Oscar? Yeah, so we see that our first coefficient is already 1, so we don't have to worry about dividing by that first coefficient. So we can move straight to the third step, which is adding b over 2 squared to both sides. And so in this case, we have 6 over 2 squared. It's going to be what we add. And we need to add it to both sides because we need to make sure that they're equal. That's it. And now let's clean it up and make it look a little bit nicer so it'll be easier to solve. And so we have x squared plus 6x. 6 over 2 is going to be 3, and then 3 squared is going to be 9. So we'll add 9. And whatever we add to the one side, it'll be the same on the other because we added the same thing to both sides. So we'll get 11 plus 9. Now this quadratic right here, that's our perfect square trinomial. That is what we want to factor. So we know when we factor, we're going to get 2 of the same factors. And if we look back up to our x squared over, or our b over 2 squared, the inside of that quantity, that b over 2, that's going to be the same thing that we're going to add. So 6 divided by 2, that's 3. And so you can do x plus 3 and x plus 3. If we look, we know that 3 plus 3 equals, or combined to get 6, and 3 times 3 equals 9. And then we can simplify our right side. What will 11 plus 9 be? 20. So we'll put 20 right there. And because x plus 3 and x plus 3 are the same, we can compress them together and turn them into one quantity, x plus 3 squared. And this is still all equal to 20. Now we get down to the step where we need to break down the layers, and we need to get the x by itself. So what is the first layer that we need to break down? Bradley? Yeah, it's going to be the squared on the outside. So to get rid of a square, we have to take the inverse of squared, which is our square root. So if we take the inverse of squared on one side, we have to do it to the other. And a square and a square root will cancel each other out. So we're left with just the middle, which is x plus 3. And then what do we need to remember before our Algebra 1 teachers get angry at us? What do we need to put in front of our square root of 20? Plus and minus. So we always have to remember, when we take a square root, we have to put a plus and minus in front of our square root. And now, square root of 20, can we simplify him at all? So what does 20 factor into? 4 and 5, and then 4 can split into 2 and 2. So we have 2 that we can pull out and put in front. So we had x plus 3 equals plus or minus. The plus or minus always goes in front of 2, and then we had radical 5. We didn't have a partner, so he is still inside. And now what is our last step we need to take to show or to get our x by itself and to find the solution? We need to get x by himself, so we're going to take away our 3. We are left with x equals negative 3 plus or minus 2 radical 5. And 2 radical 5 is an irrational number. It's not. We can't simplify it any farther with our negative 3, so we'll leave our answer just as this. But if we remember, our answer at the very beginning was, from our graphing, was negative 7.47 and 1.47. So just to check, we're going to put our answer we have here in the calculator. So we're going to hit second quit to go back to our main menu. And actually, it's still up there from last class. To put in negative 3 plus 2 radical 5, we get the 1.47. And negative 3 minus 2 radical 5, we get negative 7.47. So it's already there, and that was the same answer that we graphed. So the last problem we're going to work on is 2x squared minus x plus 5 equals 0. So just like all our other ones, we're going to graph them first, and we're going to see what we get. So we're going to get 2x squared minus x plus 5. So looking at this graph, what do we know that what do we know about our solutions? Jordan? Yeah, so we see that this graph never touches the x-axis. So we won't have any real solutions. We won't get any real answers. So we know that we're going to get 2 imaginary solutions. And so knowing that we're going to end up with 2 imaginary solutions, what do you think the most appropriate method of solving this will be? Not solve by factoring. So if you have 2 imaginary solutions, you actually can't solve it by factoring. So that's one of the times it won't work. Yes, Jordan? Yeah, so I would recommend using the quadratic formula for solving it. So anytime you get 2 imaginary answers, quadratic formula will work. Complete the square will also work. But typically, if you have 2 imaginary answers, sometimes you end up with some ugly fractions, and so quadratic formula works better with fractions than complete the square does. And so we'll copy down our problem, and we'll work out this one. So the first thing we always need to do when we try to solve by quadratic formula is we need to get all of our variables in our constant, sorry, that should be x squared. We need to get all our variables and constants on one side and equal it to 0 on the other. And so we already have it in this form, so we can start off. Now, what's the first thing we need to do for our quadratic formula? Or the next thing we need to do? We want to find what a equals. So a equals 2. What b equals would be negative 1. And we're going to rewrite that. B 1. And then lastly, what c equals, which is 5. then using these values, we're going to plug them in for a whole formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. So now we just have to put our values into our quadratic formula, and we'll see what we get. So negative b is going to be negative 1 plus or minus square root of negative 1 squared minus 4 times 2 times 5 all over 2. We have to remember that the whole top, or a whole numerator, is over the 2. It's not just the not just the square root, but it's also the negative b plus or minus. And so now, yes, Jordan. Oh, that should be a 2, right? Or yeah, 2. Thank you, Jordan. Okay, so negative 1 with the negative. So these are the negative 1, which is the same as positive 1. So we'll have 1 plus or minus square root. And what is the square root of negative 1? Or the square of negative 1? Tiffany? Yeah, the square root of negative 1. I'm sorry, I said the wrong thing. What is the square of negative 1? So it would be negative 1 times negative 1, which are, yeah, so we'll get positive 1. Then this is minus 4 times 2 is 8. 8 times 5 is 40. So we will have 40. And then 4 times 2, or 2 times 2. Now we need to simplify our square root and clean that up a little bit. So we have 1 plus or minus. What is 1 minus 40? So we will get Jordan, negative 39. And that's all over 4. Can we simplify negative 39? Yes. So, because it's a negative, we want to pull a negative 1 out. And we'll have 31. So what is the square root of negative 1? It's like Tiffany said earlier, it is I and I. So, because we have 2 i's, we can throw 1 into the front. And then 39, that'll split up into 3 and 13, which are both prime numbers. So we will leave it as 39. So we have 1 plus or minus I radical 39 over 4. And this is what x equals to. And so we see that we got our 2 imaginary answers, 1 plus I radical 39 over 4, and 1 minus I radical 39 over 4. And that was our 2 imaginary answers from before.